Now basically this allows us to kind of focus in on this design task, and this is what we're going to be looking at. So the first thing that we're going to do is let's go ahead and open up this subassembly so we can kind of work just in this subassembly itself. And you'll notice here that we have in this case some linkage that basically pulls up the mower deck. And so in that case, what I'm going to do, since we've in place activated, I'm going to go to this subassembly's display configuration and go to the moving linkage so we can just focus in on our design task for this. Now you'll notice that we have this linkage here, again, that, as I mentioned earlier, that's going to lift up or lower down the deck. And if I just go over and drag, you'll notice how the assembly relationships keep all of the parts together, and everything appears to be put together so that it'll all move as it should. So what I'm going to do at that point is, before we go into the explode, render, and animate environment, I want to apply a motor so that we can actually animate this particular motion of this linkage. Now you'll notice up here under the Home tab we have a command called motor, and it's going to create a rotary or linear depending on what you select to do here. Here in this case we're going to use a rotation, and we're going to use 30 degrees a second, and for our limit I'm going to set that to also to 30. And once we've done that, basically all you have to do is identify where you want the motor applied. So I'm going to pick this front bar, and then I'm going to give it a direction. Now obviously I can change that direction through the ribbon bar here very easily, but once we're done, basically it's going to add that motor to our pathfinder. So at any point in time, if I need to go back and make a change to that motor, I can do it very easily. Now if we want to make sure that the motor is going to do as it should, we can always simulate it very quickly, which brings up the animation editor, and in this case you can see that it added it to a timeline here, and if I run this, you notice it moves down 30 degrees and then it stops. So that's exactly what we're looking for. So in this case we will just go ahead and get out of that, and we now have our motor applied, and we know that it's going to move our linkage down. So the next thing that we want to do is let's go ahead into the ERA environment. Again, explode, render, and animate. And the first thing that we're going to look at when we get into this environment is the explode environment. Now again, the neat thing about using explode is it better helps you to better visualize parts, to better see how they maybe are assembled together. Also, when you create an explosion, you can bring that exploded view into draft to help you build technical or service manuals. So exploding your parts becomes very key to that type of work, and you need to have the tools that you can do that you can actually take these parts and create the explode that you're looking for. We have two methods. We have an automatic method where it just explodes either the top level assembly and all the parts under it, or sub-assemblies, and we also have the manual method. Now I'm going to use the manual method in this case and just work on this front corner. And you'll notice all I have to do is identify the component, and then I just have to tell the system what component I want to explode it off of. In this case I want to go down, and I'll just go ahead and leave that default distance, and you notice it pushes it down. The next thing I'm going to do is I'm going to come over and I'm going to grab the two nuts on the end of these bolts here, and I want to explode them. And I want to explode them out from the back side of this rod. So we want to go in that direction, and it allows us to move them as a unit or spread components evenly. We're going to move them as a unit, and we'll go ahead and accept that. We also need to move this shaft down, and so I'm going to pick the lower face to move it down, and then we want to move the nut, and we want to move it upwards, and then finally we want to move several components outward away from this particular assembly. And you notice I selected several components, and when I pick the direction, you'll notice that again it comes up. Anytime you pick more than one component, the system gives you an option to move them as a unit. In this case, we're going to use the spread components evenly just so you get a better idea of what that does. And then we'll go ahead and explode them. And you notice it moved them all out evenly away from the rest of the assembly. Now obviously we also supply our users tools to manipulate the explode once it's created. For example, the drag component is probably the most powerful. If I, for example, select this and accept it, you notice a triad is connected, so I can easily move this component. You notice how it adds a jog in our flow line. So again, very easy to manipulate. If I grab the drag component again and grab this component here, because I have multiple components or dependent parts turned on, as I move it, all of the dependent parts that are attached to it will also move. So maybe I want to tighten this up a little bit. It allows me to do that very easily. Now, once our explode, or in this case our explode, is created, I do want to point out that in Pathfinder we do show you the parts that are exploded, and you notice we created independent groups for those components that we selected. So again, we allow you to go in and actually manipulate any of the components or any of the groups that you created after the fact. One thing I think is important to do is once we have this explode created, we need to save it so that we can utilize this. And so I'm going to call it linkage explode. And now we've got that saved. So again, being able to come in and explode your components so you can better visualize the components and how they actually work within the assembly and how they can be actually assembled together, or even if you're just building technical or service manuals where you would take this into the view into the draft environment and add balloons and a parts list, so people get a better idea if they're looking at a technical manual what part is what. That's how the explode can be used. Another benefit to the ERA, explode, render, animate, is to be able to animate these components. So I'm going to start up the animation editor, and again it's going to bring up this timeline much like we saw earlier when we applied the motor. The neat thing about the animation editor is that we can apply motors. We can also apply the explode, where we can implode or explode while it's moving, and we can also change appearances and even create different camera paths if we need to. But in this case, I'm going to go ahead and grab that motor that we created initially and add it to our timeline. Now once that motor is added to the timeline, there's other things that we allow our users to do. For example, this is just the assembly moving down 30 degrees. So what I want to do is I want to copy it, and once it moves down, I want it to mirror this so that it moves back up. And I'm just going to move it up next to the other motor. So now it's going to move down, and then it should move back up. Another thing that I would like to do is I'd like to take that explode. So I'm going to edit that definition. I'm going to select that display config we called linkage explode. And what I want to do is the initial state will be exploded, so we'll implode this starting with the innermost parts first. And all of this is available to change at any time. When you do that, it adds all of the exploded components to your timeline. And what I can do is I can basically collapse that and just work with this one, the top level explode. And what I want to do is I want to shorten it up so that we can see it all in one few frames here. And I'm going to shorten it up to let's say 100. Now once that's done, at that point this is moved down and up and then is imploded. So what I'm going to do is I'm going to copy this again, the motor, and I'm going to paste it, and then I'm going to copy this and mirror it. So those are the motors. And then what I can do is I can take the explosion, where this will take and run through the implode. I'm going to copy, and then I'm going to mirror it. And so now we've got not only the motors moving the parts up and down, but we implode and then we re-explode. Another thing that can be done is maybe we want to apply colors. Maybe we want our customer, or somebody that we're showing this to focus in on a specific part. Well, we can come down to the appearance command, and I can select, for example, one or multiple components and accept it, and then I can tell it I want it to start with a specific color. Maybe in this case I'll pick brass. And then maybe I want it to finish in a specific color, and I can tell it to use its part style, which is this blue part style. Now I can even come down and tell it to pick maybe a white clear where you wouldn't even see the model. But in this case I'll leave it at brass, and we'll just kind of see how that works. And you'll notice it adds it to its timeline that we've created. And I'm going to shorten it up so it only occurs during the explode and implode. And then I'm going to copy, and I'm going to mirror it because I want it to go back to its normal color when it re-explodes. So once our timeline is created, and you can see how easy it was to manipulate this, I'm basically going to collapse this down, give us a little more room to see the animation that we created that includes the motor, the explosion, and then the change of color of the components. With that, we can come down, we can change the speed at any time, but I'm going to go ahead and just run it, and you'll notice it moves down, back up, and then it begins to implode the parts in the order in which I selected. It goes down and back up, and notice the color. As it's exploding, the color's going back to the gold part. Again, the animation editor is a very powerful tool, and again it allows you to visualize how components will move or interact with each other within the assembly. And it kind of gives you a better idea how parts can actually be assembled if you want to look at it in that aspect. So the animation editor, again, a nice benefit to our users. Now once I come back out, I'm going to change my display config back to the all parts on, actually moving linkage. Okay, and then we'll go to the moving linkage actually, and then the other thing that I think is important to see here is the rendering capabilities. And really the cool thing about rendering is that our users can use a rendering to create technical illustrations, create rendered images for company manuals. There's a lot of really nice capabilities where you can create some really nice rendering. And by rendering the scene, what it will do is it will also add a couple of tools that we can go in and manipulate what the image actually looks like. So what I'm going to do here is I'm going to focus up a little bit just so we get a full render here and re-render that scene. And you'll notice it's using a background color of gradient blue. It also has a shadow. And anytime you render a scene, we have a session entities Pathfinder on Pathfinder. So on that session entities, these are the entities that were used to build this rendered scene. If I want to change the background, I can simply edit the definition, go to that color, and maybe I just want it to be white. You'll notice it does give me a view of what that will look like. So when I re-render this scene, it's going to use the white background. There are some other capabilities if you want to change the materials that were used on the different components. You can do that. If you want to change the lighting, you can do that. But we also have some predefined archives that can be used. For example, I'm going to change my light studios. I'm going to go to high contrast. And in order to apply any of these predefined attributes, you just simply drag them into the view. Now it's not going to render until I actually tell it to render, but I'm going to drag this left spot with back into the view. I'm then going to change to the materials. I'm going to go to the metals, and under chromium, I'm going to grab the chrome plate and I'm going to apply that to this L bracket. Now there are 4 of them, and it recognizes there are 4 of them, so I can apply to all occurrences. Some other changes that I might want to make. Maybe I want to change this cross bracket to a brass, antique brass. We can easily do that. Some other things. Maybe if we go to finishes, I can go to painted finish, and we'll go to a flat paint, and maybe I will make the bolt black. And it's going to apply it to all of those. So we've got chrome, brass, and black. Now what I'm going to do is I'm going to go ahead and run the render scene, and you'll notice the difference in the colors it applies. So it shows you how you can come in and manipulate the actual components as you change attributes and then render the scene. And if I zoom up real close, it kind of gives you a better idea of what this actually looks like. You notice the reflection in the chrome plating of the bolt. Again, being able to do this allows our users to actually create some very sophisticated rendered images that they can use for, again, technical illustrations and company manuals. And so this gives you a really nice idea of all of the capabilities within the Explode, Render, Animate. We call it the ERA environment. So with that, I'm going to close, back out, and go back to the top level, where you can continue on with the demonstration of the Iron Eagle. But hopefully you've seen some great benefits to the Explode, Render, Animate environment, and this concludes this demonstration.